Good afternoon, and welcome to the inaugural webinar of the webinar series that's a collaboration between the National Institutes of Statistical Sciences and the Federal Committee on Statistical Methodology, AI in Federal Government, Uses, Potential Applications, and Issues. This is a new webinar series that we're collaborating on that's designed to offer something for everybody, every federal staff and supervisors at all levels with various levels of experience in AI. We plan to feature use cases that can span agencies and departments and disciplines. And we're going to be presenting AI use cases by modalities like text imaging, and also for challenges like targeted webinars for examining the implications of AI for ethics and confidentiality and privacy and organizational barriers. And we do hope with this webinar series to push ahead and see how the cutting edge AI enhancements may be available for all of us in the years ahead. So with that, I'm going to turn it over to David Matteson for opening remarks. And I'll introduce Dave here. Dave is a director of NISS, Associate Professor and Associate Department Chair of Statistics and Data Science at Cornell University. He is currently the founding and editor-in-chief for Data Science in Science and an associate editor for the Journal of Econometrics and Statistica Sinica. He is lead PI and director for many NSF-funded projects. He is an officer for the Business and Economic Statistics section of the American Statistical Association and a member of the Institute of Mathematical Statistics and an International Biometric Society. Thank you, Dave.
Thank you so much, Jennifer. Welcome, everyone. This is the opening event in the new AI in Federal Government series, and more events will be announced soon, and we hope to culminate this series with an in-person event in the DC area this spring. So this timely series arose from collaboration between the FCSM and NISS, the National Institute of Statistical Sciences, especially out of the NISS Government Affiliates Committee, and in partnership with NISS's long-term collaborations with NAS and USDA. NISS is a 30-year-old research nonprofit founded by the leading statistical societies at the time. Its mission is to seed, foster, and deliver cutting-edge research in the statistical and data sciences, and that's why we're here today. NISS aims to cut across disciplinary boundaries and sector boundaries. NISS aims to, in general, partner and support to strengthen ongoing developments across our entire profession, and in particular to lead when there's important gaps or new opportunities arise. NISS has a vibrant affiliates program with 50+ members. If you haven't heard of NISS before, I encourage you to check out NISS.org. We have new programs launching in the coming months, including an upcoming theme semester research program, joint postdoc and pre-doc programs, and a new NISS co-laboratory for seeding new projects and long-term collaborations. So I want to thank all of our organizers, our distinguished panelists, and then the staff for all their efforts putting this together. Thank you very much. Back to you, Jennifer.
Thank you, Dave. And as a member of the Federal Committee on Statistical Methodology, I'll just say that the Federal Committee on Statistical Methodology, or FCSM, is an interagency committee dedicated to improving the quality of the federal statistics. I think it started off being focused on the federal statistical system and the primary federal statistical agencies, but now we are very committed to improving the quality of all federal statistics. So it's an exciting time for AI. I think many of you may have seen that the White House issued a new executive order yesterday, which I think we're going to hear more about that coming up. So what we're going to do today is have introductory perspectives from each of our 5 panelists. I will be posing a set of questions to these panelists afterwards, and there will be time at the end for audience questions. And in the interest of just moving ahead with it, I'm going to introduce our first panelist, Chris Marcum. Chris holds the current role of Senior Statistician and Senior Science Policy Analyst in the White House Office of Management and Budget, Office of the Chief Statistician of the United States. Previously, he served as the Assistant Director for Open Science and Data Policy at the White House Office of Science and Technology Policy. In that capacity, he advanced the Biden-Harris administration priorities on restoring trust in government through scientific integrity and evidence-based policy making, and delivering a more equitable, accessible return on the American public's investment in federal research. Chris?
Thank you. Thank you so much, Jennifer. And thanks, of course, to NISS and to FCSM for inviting the Office of Chief Statistician to provide some perspective on the sort of very fast pace of artificial intelligence as it's interfacing with the federal statistical system in this day and age. As Jennifer mentioned, yesterday, President Biden signed the executive order on the safe, secure, trustworthy development and use of artificial intelligence. The order represents really an enormous breadth of government actions that promote responsible entry into the artificial intelligence space, not just for use in the government, but really across society in each of the primary sectors that have equity in artificial intelligence. I thought it would be a good idea to level the playing field in my comments, my top-level comments, in highlighting that the executive order sets forth consistent definitions of artificial intelligence and artificial intelligence models, really so that we are all understanding what we're talking about, because there have been many definitions out in the field, and often those definitions are speaking past each other, and so we thought that it would be good to anchor the terms used in the EO. The term artificial intelligence, or AI, is used in the EO as having the same meaning set forth in the AI and Government Act of 2020, and that's a machine-based system that can, for a given set of human-defined objectives, make predictions, recommendations, or decisions influencing real or virtual environments. AI systems use machine and human-based inputs to perceive real and virtual environments, abstract such perceptions into models through analysis in an automated manner, and use model inference to formulate options for information or action. The EO goes on to also define the term AI model in a more expansive way to mean a component of an information system that implements that artificial intelligence technology and then uses computational, statistical, or machine learning techniques to produce some outputs from a given set of human supervised or unsupervised inputs, really. Now, because the definition of AI model hinges on the deployment of the technology itself, it protects a bit against the scope creep by excluding the traditional deductive statistical methods that we all have used for our inference. Now, there are important equities in the federal statistical system in the executive order. Firstmost is how the executive order reaffirms that the federal government will ensure that the collection, use, and retention of data is done lawfully, is secure, and mitigates against privacy and confidentiality risks that we care quite dearly about in the federal statistical system. The executive order also instructs agencies to make headway into the development of privacy-enhancing technologies to ensure that America's protected data remains secure from those risks and from the risk of unlawful disclosure and use by AI systems. Provisions are fully aligned with Title III of the Evidence Act of 2018 and with OMB's responsibilities for promulgating regulations for secure access to confidential statistical data. Our other equities for the federal statistical system from the executive order include how commercially available information is obtained, quality controlled, shared, and used by federal agencies. And the EO directs OMB to consult with the Federal Privacy Council as well as the Interagency Council on Statistical Policy to inform potential guidance to federal agencies on ways to mitigate privacy and confidentiality risks from agencies' activities related to commercially available information. So this is data that we might buy and enter and then use in an AI model, and that has to conform to the same standards that we would normally use for information quality control and dissemination. We know that the federal statistical system will lead in the safe, secure, and trustworthy development and use of AI. recognized statistical units and agencies and the principal statistical agencies of the federal statistical system have subject matter experts in data collection, curation, methods development and analysis, and thought leaders in how emerging technology can best serve our constituents and users. We're looking forward to working with agencies in the system to implement the EO within their authorities and capacities and to leverage that expertise. And I'm looking forward to the Q&A.
Thank you, Chris. Our next panelist is Dr. Xuming He. Dr. He joined Washington University in July 2023 as the inaugural chair of the Department of Statistics and Data Science. Previously, he served as the H.C. Carver Collegiate Professor of Statistics at the University of Michigan. He is a renowned leader in the fields of robust statistics, quantile regression, Bayesian inference, and post-selection inferences. He is also a proponent of the interdisciplinary research in data science. Dr. He.
Thank you, Jennifer, for the nice introduction. And also, I'm grateful for the opportunity to be able to share my comments. Let me first make sure I have the full screen shared. Okay, great. For those of you who are at my age, you may still remember AI from science fiction before the powerful computers became a reality. When I was an assistant professor actually at the University of Illinois, Urbana-Champaign, I was among the first actually to use Mosaic, which is the first web browser developed there. Since then, computer power and the internet have given a new life to AI. Now AI is being talked about everywhere in the public and the private sector. So obviously, AI depends on logic and algorithms, and AI advances most when machines can learn from data and experience. So many in the world actually have considered AI as a transformative force in the digital age. It's really becoming a very hot topic. Just a few days ago, Oliver Chingaya, who is actually the director of African Center for Statistics for the UN Economic Commission, also a vice president for the International Statistical Institute, wrote a very nice piece entitled "The Future of AI in Statistics in Africa. Is the Continent Ready?" And I also want to mention Singapore, a small island nation in Southeast Asia, that's pursuing national AI strategy in a journey to smart nation. And their action book made it very clear that the government and business will use AI to generate economic gains and improve lives. There's no doubt that the world looks to the United States federal government as a leader in the AI use. The National Artificial Intelligence Advisory Committee, also known as NAIAC, just issued its year one report a few months ago, and their executive summary starts with the United States is facing a critical moment, a moment of both significant opportunity and complexity. Now, obviously, I wish that the NAIAC has more statistical representation. I'm not going to repeat what Chris has already talked about in terms of what AI is, because the question I think right now is not what AI is and whether we need to embrace AI. The question is how to turn AI into a powerful and responsible machine intelligence in federal government. I would view AI as a very sharp knife. If you use it right, it's incredibly useful. If not, then you can get hurt actually badly. Coming back to statistics, I will say the statistical principles and methods are more closely related to what I call human intelligence. Statistical thinking and statistical approaches focus more on understanding, information sharing, experience sharing, and idealized models. When I say understanding, I really mean understanding at different levels, including data collection, including who might have responded to a survey, what might have been learned from domain experts, and when we need to take corrective actions, and so on. So my main point today is to say that integration of machine intelligence, as represented by AI, and human intelligence, where statistics is really a certain part of it, is what we really need. So AI is developing really rapidly to mimic certain part of human intelligence. Over time, more and more human intelligence will be integrated into AI. So I believe the statistics community can help this process, even though it's often the case that at the end, very little credit is given back to the statisticians. If you think of a statistical part of a human intelligence as a pool of 100 different seeds, as 10 of them get absorbed into AI, we will be and should be able to generate 20 more. Because human intelligence has unlimited potential, especially when embrace machine intelligence to help us think further and do more. Why is statistics so important? Why is human intelligence so important? Because machine intelligence itself is limited to what is designed to offer. When it comes to ethics, bias, discrimination, accountability, and so on, machines are usually unaware of the causes and consequences. So public trust will then become a major issue. While we often hear about epic failures of AI, and we are constantly amazed of what AI can do for us. So I would call for more emphasis on human intelligence, including foundational as well as interdisciplinary research and training built on well-researched statistical principles and methods. At the same time, more openness to machine intelligence to promote better cooperation of statistical principles into the AI. I think that this is the responsibility of everyone in the statistics community, whether you work for the federal government or not. Let me end my remarks by saying that human intelligence and machine intelligence must work together hand in hand as we will dramatically quicken our journey to smart nations. And machine can get smarter and more responsible, and humans get even smarter. Thank you for listening.
Thank you. I do like the image of humans getting even smarter, rather than some of the dystopias where we see humans getting even less smart. Our third panelist is Dr. Bhramar Mukherjee. Dr. Mukherjee is the John D. Kalplesh Distinguished University Professor and Chair of the Department of Biostatistics, Professor, Department of Epidemiology, and the Professor of Global Health all at the University of Michigan's School of Public Health. It's a lot. She also serves as the Associate Director for Quantitative Data Sciences, the University of Michigan Rogo Cancer Center, and has been engaged with the University of Michigan Precision Health, an institution-wide presidential initiative for the last decade in various roles. As of 2023, she holds the position of Assistant Vice President for Research Data Services Strategy, and is the founding director of the University of Michigan Summer Institute on Big Data. Her research interests include statistical methods for analysis of electronic health records, studies of gene-environment interactions, Bayesian methods, shrinkage estimation with strong collaborative areas, mainly in cancer, cardiovascular diseases, reproductive health, exposure sciences, and environmental epidemiology. Bhramar, go ahead.
Thank you so much, Jennifer, and thanks to NISS and FCSM for giving this opportunity to speak on this very important issue, which is tearing through humanity. And so I'd really like to, I did not prepare slides. As you saw that I just started as AVP of Research Data Strategy. I have been in meetings about AI and how to navigate AI and the challenges associated with AI across the University of Michigan campus. So what I say today is probably going to be more relevant for federal statisticians working in the health sector, because I sit in a school of public health and most of my work is around health data. I just want to start by mentioning that the first paper on AI by Alan Turing was way back in 1950s in terms of can machines think? This is a seminal paper. Many of us have read and heard about this paper. So why are we talking about it today? Because since last year, generative AI has touched every possible core of human life. And somebody, a historian of science, was asking me that whether I should think myself to be fortunate that I lived through a pandemic, discovery of the internet, and also generative AI. And so this is actually a confluence of factors which define our generation in a very, very profound way. So I would like to really think from a humanitarian perspective here, because I do think that we have lots and lots of good models and technology. I really love theater. So I want to start my remarks with a quote from Uncle Vanya, a play by Anton Chekhov. This quote actually is coming from 1898, lots and lots of years ago. But the fundamental question for scientists and educators is that, will those people who live after us in the course of 100 or 200 years, will they remember and speak kindly of us? So as we think about AI, particularly sitting in a school of public health, I have to remember that my job is not just to predict, but to prevent. So I think it's extremely important to think about interpretable AI, and this is not a new concept, and also remember our social responsibility as we use it. I am very enthusiastic about what we are seeing in terms of case studies. For example, I work a lot with electronic health record data, and we use a lot of heterogeneous data in order to define a phenotype, and that involves text data, imaging data, voice messages left by patients. And it takes a lot of effort by statisticians to come up with integration of these heterogeneous data sources to map into a phenotype. And for each disease, we have different kind of algorithms and NLP techniques. But what I've seen in the initial phases of even defining smoking phenotype in the electronic health record using generative AI tools has been so much more accurate than our existing algorithm. I also saw that there are many more advances in terms of even matrix factorization. And if you can imagine how many times matrices are multiplied in modern computing every day, and a fraction of reduction of time in matrix factorization is lead to humongous advantages in terms of computational time. But I do think that AI is not here to replace. I agree completely with my colleague, former colleague, Dr. Xuming, who has left Michigan. But I really agree with the point that it is not here to replace human intelligence, but really as a complementary and supporting effort to human intelligence. I compare this with our knowledge and working operations before and after the advent of internet. I remember as a graduate student growing up in India, I used to remember so many formulae, so many equations, and memorization was a big part of my graduate learning. And after the internet, we do not remember most of those formula. We look up Wikipedia, and many times there are certain errors in certain Wikipedia pages, and we have the expertise to find that. I sort of draw that parallel with AI tools, that when the AI is hallucinating, expertise will be needed. But some of the rudimentary work in terms of, say, report generation, data cleaning, if we do not want to do that, then it can expedite that work. So what is my concern? I'm very positive about making things accelerated, making things supported, and some of the work that we do not particularly find very challenging to be eliminated and taken away from our plate. So there is more white space for creative thinking. What gets me worried about the bias in the training data sets? I grew up in India, and most of the training data, if you look at the data portfolio, is not coming from the unseen and the underrepresented. If we think about data equity, and the United States may put out a mandate for equity within the United States, but I also worry about global data equity. And I want the world data map to be represented. But I do think that many of these problems are going to be addressed. I think there is a lot of advantages in terms of AI tools for, I was working on a case study of simulating synthetic data. So in terms of simulating synthetic data, preserving privacy and confidentiality, there is a lot of literature existing in statistics. And I think that the generative AI can actually contribute to that literature quite substantially. In terms of thinking about policy simulation, what kind of scenarios of policy is reasonable? Because it can mine a lot of the text and existing content, it is coming up with a lot of interesting scenarios for policy implementation, because it has, I work a lot on COVID models and how to do policy simulation. Automated report generation, I see a lot of advantages of automating that work. So I think that we have to remember that uncertainty quantification is a very key strength of statisticians and modelers, and predictive modeling and forecasting is very important, and it is the primary task, but we have to come up with uncertainty measures as well. And I do think that in terms of that uncertainty quantification, we can contribute a lot. I have been asking ChatGPT answers to a question and asking, how certain are you, using the AI tool iteratively to elicit its own uncertainty? And over time, its uncertainty estimate is changing. And I'm very, very interested in the operational, what is happening under the hood. So with that, I think I'm going to be very optimistic in terms of doing more creative stuff. And I could not agree more with Xuming that humans are probably going to become smarter because some of the other work which we do not particularly want to do would be taken away from our plate.
Thank you. One thing that makes me optimistic is that people that are really active in this area are going to help us all become smarter with AI. Our next panelist is Michael Hawes. Oh, are you there? Yes, I see you. Michael is the Senior Advisor for Data Access and Privacy. He is responsible for outreach and engagement with the Census Bureau's data users on issues related to the impact of privacy protection methodologies on the accessibility and usability of census data. Prior to joining the Census Bureau, Michael served as Director of Student Privacy at the U.S. Department of Education. Michael is a colleague of mine on the Federal Committee on Statistical Methodology and chair of its Confidentiality and Data Access Committee. He has supported numerous federal government-wide initiatives related to data privacy and confidentiality and served as a privacy consultant to the Federal Commission on Evidence-Based Policymaking. Michael?
Great, thank you, Jennifer, and good afternoon, everyone. So advances in technology often lead to new and emerging privacy and ethical concerns, and strategies that we can develop and solutions that we can use to mitigate these privacy and ethical concerns typically lag behind technological advances. So we see kind of new concerns arising in the immediate aftermath of the development of a new technology or the implementation of new technology, and then over time we see kind of the privacy concerns being identified and new solutions to address those concerns being implemented. The same is true and will be true with artificial intelligence. I think as a pattern, the more complex and opaque a technology is when it's being introduced to society, the thornier the privacy and ethical concerns can be to both identify and to navigate. In the case of AI, there are several privacy and ethical concerns that we've already identified as relevant for federal agencies, and particularly for the federal statistical system. On the privacy front, there are concerns both about privacy in the context of AI-generated information and concerns about AI being used to attack or defeat the confidentiality protections of data that are generated in more traditional ways that agencies release to the public. On the AI-generated information front, when AI models are trained on confidential information, there's substantial risk of the confidential information from those training data sets kind of leaking in subsequent interactions with the AI models. Now, there are promising privacy-enhancing technologies like differential privacy and others that can address these risks of kind of confidential information leakage from training data sets. But many of these approaches are still in the early research stages, and any successful adoption of these or other privacy-enhancing technologies would require their inclusion at the training stage of AI development, rather than as kind of a post-development privacy filter, if you will. The other major concern, which I mentioned, relates to AI being used in attacks on the confidentiality protections of data that federal agencies release to the public. We know that any public release of information that's derived from a confidential data source is going to reveal or leak a tiny bit of confidential information in the process. That's inevitable. There's no such thing as perfect de-identification. And agencies have to select and implement disclosure avoidance mechanisms to manage that disclosure risk in the data that they publish. And in doing so, they have to navigate a very complex trade-off between confidentiality protection, data accuracy, and data availability. As new kind of attack vectors on these confidentiality protections are identified and emerge, it throws that balance off. And agencies have a difficult time identifying exactly what the existing level of disclosure risk for their data assets are, and compensating with additional or improved confidentiality protections on the data they're releasing. Over the past several years, we've seen kind of new and emerging attack vectors on kind of traditional disclosure limitation methods, through things such as database reconstruction, through the increasing use of convex optimization technologies on publicly released data. And that makes agencies' jobs harder to protect the data. There is concern that AI could be successfully leveraged in new and emerging forms of attack on confidentiality protections. So we are going to have to be diligent in kind of figuring out, okay, how can existing and emerging disclosure limitation techniques be implemented such to limit the vulnerability of these mechanisms to AI-based attacks. On the ethical front, there are also concerns. There's concerns about data quality, which have been mentioned already, transparency, and data integrity. On the data quality front, the more that AI exists as a black box, the less confidence we can have in our ability to know what the limitations of our data are. As statisticians, it's important for us to know how much we can rely on the data that we are collecting and using. So to the extent that there are inaccuracies, to the extent that there is error or bias in the data that AI are generating, it's important for us to be able to identify those. That requires understanding the technologies and understanding kind of the workings of these black box algorithms in many cases. On the transparency front, a related issue is how can we communicate these limitations in the data to our data users? We have an obligation to convey known limitations on data accuracy, known limitations in the form of bias, etc., to data users in order to inform their uses of our data. If we're using AI to generate data or to process or produce data for public consumption, and if we can't be sure that we know all of the limitations of the data, how can we successfully convey those to the general public? And lastly, and particularly kind of in the context of AI technologies like ChatGPT, where they're starting to take the place of search engines. If data users are asking these AIs to answer questions that require kind of the use of federal statistics, how can we ensure the integrity of the information that's being presented as federal statistics? How can we make sure that the data that these AIs are serving up to the public, if they're being drawn from federal statistics, how can we ensure that they're both authoritative and accurate? And those are kind of some thorny questions that we're going to have to consider and find solutions to. So these are just a few of the concerns on the privacy and ethics front. They're absolutely ones that merit our attention. And as Chris mentioned at the beginning of our session today, yesterday's executive order actually addresses some of these. It instructs federal agencies to research solutions to these and to related concerns. It's also likely that as AI continues to be developed and adopted, that new concerns on the privacy and ethical fronts are likely to be identified. And so we should remain diligent, and we should continue to review these technologies moving forward to ensure that we're able to stay kind of current on how we identify and address these privacy and ethical concerns. Thanks.
Thank you, Michael. Before I introduce Nancy, I wanted to alert everybody to the Q&A tab at the bottom of your screen. We have a couple of questions, and so after each of the panelists has had their chance to provide their perspectives, I'm going to be asking a handful of moderated questions, and then at the end toward the end of the webinar, we will go through the participant questions. So your question should be answered then. If not, we will figure out a way to find an answer for you. So our last panelist, who will be giving her opening remarks, is Dr. Nancy Potok. Nancy Potok has over 38 years of senior level experience in the public policy arena within the public, private, and nonprofit sectors. Dr. Potok is a visiting fellow at RTI International and visiting scholar at NYU. She previously served as the Chief Statistician of the United States in the Executive Office of the President and the Deputy Director and was the Deputy Director and Chief Operating Officer of the U.S. Census Bureau. She was the Deputy Undersecretary for Economic Affairs at the U.S. Department of Commerce and Senior Vice President of NORC at the University of Chicago. She served as a commissioner on the U.S. Evidence-Based Policymaking Commission and currently chairs and serves on several boards of nonprofit organizations and academic institutions, including NISS. She is a fellow of the National Academy of Public Administration and the American Statistical Association. Nancy?
Thanks, Jennifer. And thank you to NISS and FCSM for having this webinar series. I'm going to share my screen. I do have a couple of slides that I'd like to use to help the conversation along. So let me get this up. Let's see. I guess I have to start the slideshow somewhere here. There we go. Yeah, so I'll just move to the next slide. What I want to talk about actually is kind of a more practical application. I'm gonna bring it down a little bit to ground level here in terms of thinking about people's desire to do AI projects themselves and how you go about doing that in government successfully. I think there are several things to consider. We're talking about some of the big ideas, some of the big considerations. And what I'd like to do is talk about, let's see if I can advance my slide, some of the elements of a successful AI approach, especially if you're in government. The technical fundamentals obviously are key. And I think there's a lot of help out there on what are the technical fundamentals? How do you actually put these algorithms together? And I think the webinar series will do a much deeper dive into this. Sometimes what people want to do isn't as complicated as it seems. A lot of it, again, depends on some of these data quality issues, what you're starting with, what you're trying to accomplish. But I think if you just kind of jump in on one particular thing, even if you're not in a management or leadership position in your organization, you still have to fit within an overall AI strategy. I think some of the panelists who came before me were kind of laying out these strategy and policy types of issues that whatever you're doing, however big or small your project is, really has to fit in that context and under that umbrella of the executive order if you're in government. But the other thing to consider too is your organizational culture, because if the organization isn't ready to accept some of the things that you want to do, you could have a heck of a time moving your project forward. And then what is the governance structure? I mean, I think for many people in government, it's not so much that you can't conceive of a project that you don't want to innovate. It's sort of, how do you get things done through the governance structure? Now that we have chief data officers, there's CIOs, you need infrastructure. That might be your biggest barrier, actually. So while you learn about AI, you have to keep these other kind of environmental things in your mind if you're really going to get this done. And then I think Michael spent some time talking about responsible leadership and the ethical framework within which you work. So there are equity issues, there's data quality issues, there's many things you have to consider. And I do want to just do a very short deep dive into this, but I strongly recommend that as you're considering what you want to do in your agency, whether it's a research project or you think you want to buy something off the shelf or you're ready to launch, you really need to create a roadmap before you start. And these are just my suggestions based on my own experience and the experience of lots of other people that I've interacted with across government who are working on AI projects. And that is, you start sort of by having a value proposition. Why are you doing this? What is it going to contribute? I think that goes back a little bit to what Bhramar was saying about what are people in the future going to think about this? Where is the value? Why? So you start with that. It needs to tie into whatever the mission of your agency is, and whatever you're trying to accomplish. Why does that matter? How are you going to, the third thing, create a narrative that explains what you're trying to do so you can get some support in your agency for doing this and kind of get a supporting coalition together, whether it's people in other agencies or in other parts of the agency where you need to get your hands on the data, you need help with the infrastructure, you're going to need some money and people. I mean, these are just very practical considerations, but if you don't sort of think about this, your AI project may be very well conceived, but it's not going to go anywhere. And then how do you set up maybe a pilot project so that you can have a deliverable and show some progress, communicate your vision, get more buy-in. I think a lot of people set out being just overwhelmed because they're trying to, as they say, boil the ocean. The scope of what you're trying to do is just way too big. And so, if you really want to be successful, start with little things that you can do that will sort of incrementally advance your research or your particular project that you're trying to do. It doesn't mean go super slow or don't, take any risks. But I think if you have a smaller scope, if things aren't working out very well, you have something that's manageable that you can course correct and think about some of these other issues. And I think one of the big problems that we see is that people kind of conflate their ability to get things done in the AI arena, the technical problems and the adaptive challenges. I think most people actually don't run into huge problems. They're kind of fun problems, the technical ones. And you can find people who have the technical background, whether they're inside the agency in an academic setting that you want to partner with, an organization like NISS who can bring in experts. You can tackle those technical problems, but if you don't think about the adaptive challenges, sort of where do the people come into this? How are we having to learn new ways of behaving? How is this changing attitudes or behaviors? You could really run into a lot of resistance and fear. And so sometimes those adaptive challenges are actually tougher nuts to crack than the technical ones. And if you're not thinking about that as you go along, you could end up with a big surprise when people kind of resist and say, well, you're taking away my job. This is where, as a statistician or as a somebody who's supporting statisticians, where I've always done this work my way. Now you want to do it this different way, and it's going to take away my job. So I don't want you to do it. I mean, you may not hear that exactly, but you will be hearing that as a subtext. And then Michael kind of went through some of the ethical issues, and so I won't spend a lot of time on this. But I think these are ethical issues in statistics, and they carry right over to AI. The privacy bias, and it is like missing data is huge in bias. So I'm glad that was brought up. Who's not included in the training data or in other data that you might be using? This idea of transparency, especially if you want to go out and buy data or buy a software product that's going to, do some of this for you. So fairness ties into that. Accountability, who's responsible when you're not quite getting the results that you want, because this is a team effort. It requires coalitions of people. You can't sort of sit alone and do an AI project. So understanding the various roles and responsibilities. And then I think the most important thing in some ways is explainability. How are you going to really maintain trust in government by being able to explain in very clear language what it is you're doing and what the effect is? And you have to not only be able to explain it to other statisticians, but to the public, because you're still going to probably be relying on public data one way or the other. And so when you get to this, and let's say you have all these other things kind of tied in a neat package, you've got the technology, you've tested your technique, you've got some support in your agency, you still have to stop and ask yourself, is this really something we should be doing? Is this something that people in the future, again, will thank us for, or are we going to deeply regret this because of some of these fairness and bias issues, or violating privacy, or really ending up with some trust issues out there between the public and the government? So it's not just can we do it, it's should we do it? And if the answer is pretty iffy and you're not sure, don't do it. You have to be prepared to stop. And I think that's a really key thing too. You could get very close to being able to do something and just say, you know what, we shouldn't do this from an ethical standpoint. So I'm going to stop there so we can get to some of the questions that are, both the policy and kind of the statistical application, and these kind of practical things that you really have to think of if you're actually going to be doing this in a government setting.
Thank you, Nancy. And so, like I said before, if you have questions for the panel, you can put them in the Q&A. But first, we have some questions from NISS and FCSM for the panel. And I forgot to say, I didn't introduce myself. I'm Jennifer Parker. I'm the director of the Division of Research and Methodology at the National Center for Health Statistics, which is located within the Centers for Disease Control and Prevention. And I am also on the Federal Committee on Statistical Methodology. And so it's been a pleasure to hear all of the perspectives and insights from all of our panelists. And I have a handful of questions here, but I have actually even more now that I've heard everything laid out. So my first question for the panel is, what are some of the considerations that government statisticians and managers should be thinking about when deciding whether to use AI for a particular use case or as part of their workflow? And I think all of you have touched on that a little bit. I do have a second question related to this that could be answered as part of this answer. What special issues arise because AI methods are not transparent, which is a fundamental value of the federal statistical system and federal statistics in general. I am going to let somebody volunteer to open up, and if not, I will call on somebody. All right. I'd like to hear from one of our academic colleagues. Xuming, would you like to take a chance at answering that?
Sure, I will try. I think the question is, what are the considerations the government statisticians and the managers should be thinking about when they're deciding whether to use AI for a particular problem. I think that the key question for me is to think about, do we really understand what AI or the particular AI method we are using, how this is working, how it arrives at those conclusions, and whether certain human interventions, whether out of the more part of the human intelligence, is it really needed in arriving at the solutions. So I will certainly feel uncomfortable just blindly use whatever tool is available, whatever algorithm or platform is available. If we feel comfortable, we understand what the AI is doing for that particular problem, reaching that particular conclusion, then I will say, yes, this is a very powerful tool that we should rely on, and we may be able to get things done more efficiently and getting better insights. So that's my quick answer. Jennifer, you are muted, I think.
I thought I would get through today without that. Thank you very much. I see, Chris, you have your hand up. Do you have a response or another answer?
First, a concurrence with Xuming on all regardless of the tools, that if you don't understand the tools, perhaps you shouldn't be using them. But I just wanted to point out that we often refer to this as the black box problem, where we understand pretty well the inputs. Although when you're talking about inputs on the order of billions and billions of parameters, it's often very difficult. And as we know, for those of us trained in statistics, as you know, we can often end up in situations where there's really complicated interactions that we don't quite understand that come out. And so it's really, I think, very important to have open standards, to have the protocols themselves to be open, and for the underlying algorithms to be visible to the public and visible to interrogation. The other thing I would like to add on this is something related that Michael had talked about, which is one of these really difficult challenges with transparency here is in data quality. And so we often care a lot about confidentiality, obviously. And one of the trade-offs, of course, of that is that we want to protect confidential data. If models aren't trained on the very best in high quality data, then their outputs will reflect that. And so we have to really think very carefully about, I think this is really an existential question for the federal statistical system. Think very carefully about what the balance and trade-off is between what we allow models to be trained on, so that we can transparently communicate to the public the trustworthiness of the outputs when there is still a substantial disclosure risk.
Mm-hmm. Very good point about the quality of the inputs. Bhramar, I see you have your hand up.
Yes, so I just wanted to make a couple of comments. One is that I think it would be incredibly important to collaborate with industry. So at University of Michigan, we have created our own version of UMGPT, where the data inputs are actually secure. So, but the underlying operating system is actually in collaboration with Microsoft. So I think that industry partnership with industry is going to be very key in terms of creating secure environments where we can use all of these tools and we can lead a AI augmented, meaningful, purposeful life as an analyst instead of being AI driven. That's the first thing I want to mention. The second thing is that productivity. So already by my students who use actually GitHub Copilot in terms of filling with codes are producing work much faster than students who are resisting. So Stack Exchange is their default, but how much different is it? And so why should I be resistant to use GitHub Copilot? So for coding and translating a syntax of code from Python to R, I think this is absolutely a very good use. You still are not going to get absolutely accurate coding, but you can fix it. It's 80% correct. So your starting point, taking a Python optimization routine to R, is much faster. So that gives me hope, but also concern, because I feel we already produce a lot. And the June 2023 McKinsey report says that $6.1 to $7.9 trillion added to the economy because workers will be more productive. And the projection is that by 2030, 30% of the work hours are going to become automated. So in academia, if now I am expecting my junior faculty to produce more, I'm going to place that as a question. And then the third thing I want to mention is sample survey and study design. Many of the assets, and I think that the national treasures in government statistics are ongoing national surveys. And many times the AI tools just takes data as data, does not really respect the sampling design. So we need to really work in partnership in order to respect the study design and how data are collected. And that's very unique to our field.
Thank you. Michael, I think I saw your hand up next.
Yes, so I just wanted to follow up on two things that Chris had mentioned. So the first, I absolutely want to second what he was saying about how thorny the balancing act can be between ensuring data quality and data protection. And I think in the AI context, that can be even more challenging than it already is, which is not reassuring. But it's certainly something that merits a lot of thought and consideration. The second gets back at the transparency part of the initial question there. And I think Chris did a really good job of explaining the importance of algorithmic transparency as part of that, kind of moving away from the black box nature of a lot of discussions about AI. But I think it's more than just kind of like opening up the black box and having transparency in the algorithms. I think the other part of this that's going to be particularly challenging from a transparency front is going to be explaining to non-technical audiences, but audiences that are using the data that are produced from these algorithms, explaining to these non-technical audiences exactly what's being done to create or to process these data. Because this is a highly complex technical domain, and it's not going to be easy to explain, and particularly not going to be easy to explain to those who are not kind of well-versed in this type of algorithmic decision making. So I think we're going to have our work cut out for us on that kind of transparency front if we're going to be able to explain kind of what's being done to the data and what the implications on data use are.
Making these problems even greater for the federal statistical system. Nancy?
Yeah, thanks. I would like to kind of posit a different thought here, maybe a little bit of a different perspective that I don't think is being talked about much, but could be helpful. And that's really kind of in a governance/autonomy context of thinking about the government and particularly statistical agencies doing AI. We want openness, we want transparency. The agencies also want a lot of autonomy when it comes to their methodology, and I think transparency helps with that. But if we look at some international models, for example, not technical models, but governance models. If you look at, for example, the UK, they have a really sophisticated oversight and evaluation capacity where they have kind of what I would say an intermediary between an independent statistical function, the Office of National Statistics, and the public, that kind of gives the seal of approval in a non-technical way by providing this oversight. And we don't really have that in our governance structure. I don't think OMB and the Chief Statistician's Office right now is set up to be able to do that the way that they do it in the UK, because it's tied to the White House. And so that can create trust issues as well. It's like inside the government saying, oh, trust us from the White House. And we've seen that can create problems. So I would say, you know, maybe we should be thinking along with the technical solutions to these issues about maybe we need a different governance structure that can sort of look at the validation process, have the human intervention, review these algorithms technically, and then be able to turn around in a non-technical way and say to the public, here's what we found. We found bias, or we didn't find bias, or, you know, and then you don't have to reveal all of the algorithms and the micro data that you're using that could create privacy problems if you're using micro data for the training data. Because then you have a limited group of outside objective people who can sort of give that good housekeeping seal of approval and say, no, this is actually okay. So that is not part of the conversation right now, as far as I can tell, in a serious way. And I just want to put it out there as something to think about.
Thank you, Nancy. I apologize. I was telling the group I was a little bit, I had a touch of laryngitis over the weekends. So I think that's a good segue into our next question, actually. Where do you see the biggest impacts for government statistics with AI? And how can academic researchers and statistics and governments, academic researchers and government statisticians each contribute and collaborate towards the use of AI for government statistics? And I apologize for my voice. Michael?
Yeah, so I think one low-hanging fruit that I know the Census Bureau is actively looking into, and I believe other agencies are as well, and that's using large language models to better understand what people who are coming to our website are looking for, and also better being able to serve our information up to the general public in other kind of web environments. And the reason for that is, so we have very particular nomenclature for our data collections and for our data products. And we refer to things as like table P19 or table G001 or things like that. We have very regimented nomenclature for the different data products that we're releasing and for the different attributes and variables that are included therein. And that's not the nomenclature that your average person looking for an official statistic is actually going to use. And so there's often kind of a translation gap in there where kind of real language questions need to be translated into their official statistics tables, kind of official nomenclature, and vice versa. So we're looking into large language models as a mechanism for better being able to kind of perform that translation, both on the input side and on the output side, to better serve data up to the people who are ultimately the consumers of it.
Yeah, that's a perfect use. Nancy?
Thanks. Yeah, I just wanted to mention a pilot project that I've been working on. It was one that we talked about at the recent FCSM conference, and that was using, natural language processing models and several algorithms to find out who's using statistical data. What are some of, going beyond kind of the downloads from the website, and really being able to see by looking at scientific publications and reading the full text of the articles, and then looking at reports that agencies are putting out and other types of things to actually find the uncited data that's being used and the data assets that often don't show up just if you're looking for citations. And then making it available to both the agencies and the users to start really building coalitions around communities of data users, like whether it's health data or education data, or helping agencies kind of get a lot more breadth and depth by sharing data and looking at how researchers are linking data from different agencies and understanding that a lot better, so the agencies can actually improve the quality of the data and start making much better connections with the user groups. And from a kind of an equity standpoint, again, see who's missing, which researchers are not using the data, which communities are missing there, and how can the agencies do more outreach. And then tying that through better kind of search functions that could be algorithmically driven the way that Amazon is, so that when someone is coming to like the application portal to get access to statistical data, they can now see a lot of usage data. They can connect with other researchers and have a much fuller portfolio and of understanding, especially newer researchers can see that, and agencies can see it too. So I think there's a lot of practical uses out there to really help increase the public and researchers' appreciation and the value of statistical data can be demonstrated much better, which can only help the system, I think.
Yeah, I really like the focus on the external users and the general public, and making statistics a little bit more friendly for everybody. Xuming?
Thank you, Jennifer. I want to add to the one big impact, I think, for government statistics using AI is that I think the more and more government leaders will be under pressure to ask what more and how much more AI can do in federal government. And in turn, I think that people doing statistical work will be more appreciated. So that's a more optimistic view of that. And I also want to come to the collaboration between academic research statisticians and the statisticians working in the federal government. I think that obviously the statisticians working in the federal government are heavily engaged in the process. They play a really critical role, not just using AI, but also I think helping the government develop the AI policy. And that's also going to be a very important aspect of it. And we need to have multiple platforms to facilitate closer collaborations between people in academia and also in the federal government. And NISS is obviously one such platform, and I think we need all to work to strengthen that. And if research statisticians just kind of talking to people in the government at the generic level, I think that the impact will be more limited. So to me, I think that statisticians at the research, like academic statisticians, need to get to know the nitty-gritty of statistical work in the federal government. You want to get into how data are collected, what questions are being asked, and so on. So this way, by working together, people can develop much more powerful and understand AI methods and develop new powerful methods to really take advantage of what AI can offer. So my answer is really simple in terms of a collaboration. I think the best way is to get academic research statisticians and the government statisticians to get married, to live under the same roof, at least for 7 years, if not longer. Thank you.
I'm really sorry about my voice. I think I'm going to have to ask somebody else to step in. But in the meantime, Bhramar, would you like to speak next?
I'm so sorry, Jennifer. I hope you feel better soon. I just wanted to make a comment about education. I think that in the last 1 year, 8,000 AI tools have been released, and many of us are sort of swimming in our ocean of learning, and our PhDs are seeming antediluvian. And so what can we do? And I think there is a lot of effort needs to go into training and education. And I see there that universities where education is a primary force, for example, in University of Michigan, just integrating into our Canvas course sites AI tutor has been proposed. So this AI tutor is actually integrating your course notes, your lectures from the last 5 years, and providing personalized AI-assisted tutoring to the students. And if you, as an instructor, I'm sleeping at midnight, the student has an exam next morning, they can still use the AI-assisted tutor. So I see a tremendous potential with democratization of global knowledge using these tools in an equitable way. Just like, previously, before the advent of the internet and online publication system, a researcher in India had to wait 4 months to get an actual copy of a journal on paper, and it was really challenging to access information. But now it would be much more on an equal platform. And similarly, I also think that editorial tools are going to set the platform more equally for non-English speaking researchers and writers. So I do think that there are many good things on which you can collaborate, but I really want to focus on education, because I think a lot of training is going to be needed in every sector. Academia, industry, government partnership will be more important than ever.
I'll chime in next, and I think Bhramar wins the webinar for her fantastic use of antediluvian. So I wanted to kind of get back at when we were talking about like great opportunities for the use of AI in government, but I also want to kind of issue a caution, and that's the shiny toy syndrome that we see with a lot of technology in government. That when a new promising technology shows up on the horizon, there's like a race in federal agencies to see who can implement it and how it can be used, and to identify all these great new things, even if it's not necessarily the best use of technology. We saw this in some cases with blockchain. We saw it with some privacy enhancing technologies at various points, and I think we're going to see it with AI, that in the rush to be showing that you're using this great new technology, people are going to use it for things where it may not be best suited, or there may be better alternatives out there, or maybe they're not properly considering the risks. So I do want to kind of issue that concern, and that I think it's an incredibly promising technology that when used appropriately is going to serve government incredibly well, but there's going to be incentive to use it when it maybe shouldn't be used as well.
Hey, Chris, why don't you wind up this, and after you speak, we can go to the questions that are in the chat, okay?
Sure, just very quickly, first is I concur with Michael that a heavy dose of moderation might be in order for many of the shiny new toys. But I also wanted to follow up very quickly on what Bhramar was saying with respect to training. In a follow-up to that, in the executive order, section 10.2 is about increasing AI talent in government, and I think that one of the roles that the statistical agencies can provide here is really a lot of the laundry list of expertise and subject matter expertise that I mentioned in my top line comments. Because as we build out the workforce, we are going to need experts in statistical analysis. It's not just computer scientists, it's not just the IT folks per se, it's social behavioral researchers, it's experts in data quality and management, it's experts in ethics, per Nancy's comments. And so I just wanted to highlight that as well. Over.
Thank you.
Thanks, Chris. Yeah,
Yeah.
So Jen, if you don't mind, I'll kick off the Q&A and you can save your voice. Okay. So we have a Q&A session set up for the next 15 to 20 minutes. If you had a burning question, go ahead and put that in the chat. So I'll go through some of these quickly. If some of them were redundant, I might skip them based on our earlier answers. But one question for any of the panelists, maybe Bhramar in particular, could you give some quick comments on how government might be useful in preventing risks from occurring or being realized? So that AI should not only predict, but can it also prevent?
So I definitely think that, I think Miguel Hernan wrote one paper, I think a few years ago, that no artificial intelligence can be real intelligence without incorporating causal inference into it. So I think that what I was trying to allude to, that being able to predict an outcome with almost like very high accuracy is important for me, but what factors in the society can I change in order to change that outcome? And so for that, I really need to know what are the key players, and I need to apply all my knowledge about confounding, selection bias, missing data, measurement error, just having a prediction. Human health, where we sit, is not really equivalent in terms of who is going to click on an icon on an internet. So just being able to predict is not my ultimate goal. I want to understand the causal factors. And similarly, when I work in biology and disease etiology, I really want to know the mechanism, the mediation, the pathway, what is happening inside the body. And so I do think that these AI tools and flexible tools, just like machine learning, is going to empower us to make many of the choices we make to be more flexible and incorporate multimodal heterogeneous data. But at the end of the day, I should have a target estimate in mind, which is policy relevant, and also exposures and the pathways in mind on which I can intervene. And so that's what I was alluding to.
Nancy?
Yeah, another perspective on this is that for many of the statistical functions in government, they're part of a larger agency, and they're offering statistical assistance and advice and information to whatever function and mission is going on in the larger agency. So in addition to the 13 very well-known statistical agencies, there's over 100 statistical functions going on across government. And I think one of the things that can be very helpful is when you're thinking about risk, it's also like, what is the risk that's happening within the agency as well as within the world? Where's that connection? So if you think, for example, about IRS and some of the work that Statistics of Income does that informs IRS business in terms of how do we look for anomalies? What kinds of streaming data would we be looking at? How can we develop leading indicators? So from a preventive standpoint, you really want to take your predictions and turn them into leading indicators in some instances. And sometimes that involves thinking about, well, what kind of data can we be streaming and what algorithms can we be running on that would sort of set up alerts for changes in the environment. If you're doing immigration statistics, for example, what do you want to be monitoring out there in the world? It could be open data, it could be visa applications, could be all kinds of things that you would want to set up that you could help your agency with as a statistician. So I wouldn't want to leave that out in terms of how do you prevent things, or what are some of the ways that statistics are being applied across the whole federal government, not just in an agency like the Census Bureau or the Bureau of Labor Statistics, but in all these many other functions where statistical work is taking place.
Xuming, go ahead.
Yeah, I just want to second Nancy's point. I think it's very important. Last year, when I was attending the General Assembly at the UN Statistics Commission, I just realized that the United States was maybe the only country with such a decentralized federal system where statisticians work with different agencies. Most other countries, they have a central statistics office. So I think here in this country, it's even more important that the people across agencies work together, both in terms of training, education, bringing expertise, and sharing data. So maybe it's a little bit easier to share data across federal agencies. And working together, I think across agencies will really help the government do better, whether it's a prediction or whether it's try to prevent risk. Thank you.
Another question concerns how we might ensure that the free and open source AI tools that are available now stay free and open source. Does anyone have any thoughts on this? Hey, Chris, you want to go?
Yeah, I can speak a little bit about this. I mean, first of all, we can't ensure that we can't ensure that there won't be proprietorship leveraged over models in the future. I mean, that's in part what a great bit of the American investment in R&D is commercialization. However, what we can do is make good practical use of existing open resources, and then it becomes path dependent, right? It's very hard to deviate once you've adopted a particular technology. It's hard to change shift, and so by early adoption, by having really practicable security hardness testing that is done in a way that the open source community can sustain, and to have policies that allow us to use open source models and algorithms and to value the culture. The open culture is I think really primary in terms of at least federal agencies' perspective and use of this technology. I also think that the open source community has a lot to teach us in this respect because of their incredibly good metadata tracking, versioning control, et cetera, much better than many of the proprietary solutions. And it helps foster transparency, which we value.
The next question, a little bit different flavor. So a lot of the audience has advanced degrees already, but probably most of them not in AI. So how do they kind of get up to speed and embrace all the changes on the horizon without going back to school? Anyone want to take a first crack at this? Bhramar, go ahead.
So I went to a seminar. It's going to be not my knowledge, but borrowed wisdom. I went to a seminar where somebody asked, is AI going to take my job? And then the panelists responded by saying that no, but someone who knows how to use these AI tools meaningfully is going to take your job. So I think that there's a difference between actually doing research and development in AI, and there are card-carrying people who have been doing this forever, and they're going to continue to do that. And this new advent of generative AI with trillions of parameters and tuning takes a lot of GPU and computing time, and many times it's not even affordable, that level of competition for even big consortiums of universities coming together. So I do think that we are going to be there with our quintessential tools, but learn enough about AI tools and also in team science. I do think that already you can see statistical papers where prompt engineering is used because you can control the input factors and use this black box to get to the output. So how are you going to actually use basic principles of experimental design in order to do prompt design? So I do think that every quantitative discipline is going to come at it with its own spin, and our skills are still going to be highly valued. But I definitely feel that we should learn about the AI tools and the technologies that's coming, even if we do not innovate each and every one in that space. And again, I cannot emphasize more on the training piece. And Michigan has an amazing website, umgenai.umich.edu, and also has given us these two tools in terms of our teaching, which is called Maisie, as well as UMGPT, which is our local version of ChatGPT in a more secure environment to play with. We have many, many small research projects in teams so that we can learn from each other. So I think collaboration is going to become very important. I think credence, coalescence, and then luminescence, that's sort of going to be the steps in order to shine in this world. But I think we have to do a lot of work now in order to learn, which is good and bad.
That's great. Xuming?
I don't have a good answer. Actually, I have the same problem myself, right? I have an advanced degree. I'm a professor in the university. I have trouble keeping up with what's going on. So I would just like to share my, only perspective is what I'm doing is just to broaden my circle of friends, professional friends, and talk to people outside the ones that I normally get used to. I try to attend conferences and workshops that were not strictly in my own area. By talking to more people, I got more motivated. I know which direction I look at, and hopefully that will help me keep up to date. I know it's not a good answer, but this is the same challenge that I'm facing.
Thank you. Go ahead.
I think, we often get really, really excited about training the next generation, training young scholars, and we should be, because those investments are really important and really critical. But we do need to make sure that we prioritize retooling and career advancement in emerging technologies, regardless of what it is, not just AI, for established labs. And I think that NSF and others, do have a mission of that is driving that perspective. I mean, really, if you train just the new generation, let's say for postdocs, for example, what labs are they going to go into to deploy those skills if they don't have good mentorships that aren't skilled in these areas? So,
Mike.
Yeah, I'll add on, and this gets at one of the topics that Nancy really addressed in her slides, and that's in addition to making sure that we're properly training the people who are going to be using and implementing these technologies, we have to make sure that we're providing at least kind of basic education about how these technologies work to agency leadership and the policymakers who are going to be governing this and championing this within their agencies, because if they don't understand at least the rudiments of how AI works in these contexts, then governance is going to be problematic.
Nancy.
Yeah, very, very quickly. I would just say that for those of you who are looking to upgrade your skills, there are a lot of actual training courses for people who are mid-career and more, senior in the federal agencies. There's a lot that are offered online, in person in DC, if you're in DC. So I suggest that people kind of brush up on their skills in this area. Some of these take more or less investment or time, but they are, I'm aware of several of them. I teach one, and I don't want to pass up the opportunity to say that this series of webinars is exactly the kind of thing that people should attend all the way through. That's what we're doing, is kind of helping lift up people's knowledge and skills and abilities in this area through this whole series of webinars. So stay tuned.
Thank you. Thank you for the plug. I want to ask a question specifically about surveys and related methodology. What is the potential impact AI has on that space, and what are the potential pitfalls as well? Sorry for a more technical question as we're trying to wrap up here.
I won't speak to the technical aspects, but I can assure you that any agency that has a new survey will still undergo an information collection request review with the Office of Management and Budget.
Okay.
So I personally think that there could be advantages in terms of data collection and deployment of surveys, but also many times when you have massive open text boxes, then how to mine those data. I also think that data linkage with a survey and then external data sources, there could be potential for that. I personally think that how complex survey designs are used is unfamiliar to these AI tools. They just take data as data. So I think there is a lot of opportunity of working survey researchers and these prediction tools, how they can interact together. But I do think a lot of the extraction of information and integration and linkage to other data sources may become easier.
Thank you. Nancy?
Yeah, very quickly, I would just give one actual use case that people can find out more about. That Hubert Hamer, the head of the National Agricultural Statistics Service talked about at FCSM, which is that they were taking the usage data that they acquired through the natural language processing and turning that around very quickly and taking it back to survey respondents, in where they were able to target very localized research that had been done that was relevant to the respondents, and to see if getting that information in a very personalized way and very local and very centered on their interests would raise the response rates. So that's another way. It's not just sort of post data collection processing or connecting data, but it's taking it back to the respondents to raise the response rates, because they can really see how the data are being used.
Well, it's time to wrap up. I wanted to thank all the panelists again, and the organizers for putting together this really great session. I want to thank the audience too. We had a fantastic turnout today. So do look for announcements about more upcoming web events and hopefully a capstone in-person event in the DC area this spring. So thank you guys again. This was really fantastic, really a treat.